Hello to everyone and welcome. I see lots of familiar faces. My name is John Eason and I am a clinician and not a scientist. Even though I will be the first to submit that the scientists are way ahead of us on the subject of aging. That said, I would like to thank Ethic USA for the invite to discuss a subject that I am very passionate about. Now, this is the first time I am presenting to a non-all medical group, so I'm extremely excited about this talk. While I usually like to start out with a disclosure, and in most cases, believe it or not, I usually don't have any disclosure. However, this time I do have a few. Yes, I do work for Jackson Memorial Hospital, and I have been part of that wonderful institution for many years now. However, this gathering has nothing to do with Jackson Memorial. As always, my goal is to try to bring consumer healthcare information to the general public, and that's exactly what we're going to be doing today. What we will be discussing here should not be taken as a license to go out and treat yourself. It is an informational session only. However, I strongly recommend that if you are interested in anything discussed here, the first step is always to discuss this with your primary care physician, who would guide you down the pathway. And yes, I have turned my body into my own little personal guinea pig, so to say. I even have my own personal health dashboard to monitor my health. However, also in the spirit of full disclosure, I have been practicing what I preach for as long as I can remember. And people always ask, or want to know what my secrets are. I would like to stress that every case is an isolated case. And please don't do what I do just for the sake of doing something. Have a discussion again with your doctor before doing, or taking any of this supplements that we're about to discuss, or any of the measures towards anti-aging. Just avoid the temptation. Keep in mind that just because something might be a supplement and over the counter, that does not mean that they do not have side effects or can counteract adversely with maybe some of the other medications that you might be taking. Also, yes, some of the names mentioned in this discussion happen to be people that I have known for a while, some I went to school with. However, I have no financial benefits or monetary rewards from anyone to promote any agenda here. Last but not least, most, if not all, of what I have to share with you today comes from three main institutions, and they happen to be the pillars of anti-aging research, and that happens to be Harvard University, MIT, and UCLA. So everything that we will discuss today is verifiable. Today, we will be talking about the aging process, or what is commonly referred to as anti-aging, but I like to see it as pro-aging. We will take a deep dive into the theories of aging, and there is a lot of interest in this subject right now among the millennials and baby boomers. I mean, just about everyone out there is interested in the subject of aging. If I may borrow a cliche from one of my friends who happens to be out here, Mother Nature does not discriminate. She is coming for us all, hopefully not so soon. As a kid growing up, like most of you, I had so many dreams and wanting to do so many things and wanting to be so many things. However, though, as I got older, it also became clear to me that we all have a finite amount of time on this planet, and that seemed highly unfair. So moving right along, This slide sums up where we are with the concept of aging today. Yes, aging is associated with the decline of all our tissues and organs, and this is also associated with an increase in, a multitude of diseases. Although aging has long been considered a one-way street, strategies to delay and potentially even reverse the aging process have been proven and gaining interest within the scientific community. This very interesting article that was published by the MIT Tech Review during the pandemic also left not only the scientific community asking the same question: is there a limit to human life? As we move along, during this discussion, you yourself will probably be asking the same question. By looking at this slide, you may be inclined to believe that life expectancy and longevity has a lot to do with one's global zip code. And to some extent, it probably does. So why is this gender gap life expectancy, so important? Well, for starters, women generally live longer than men with a gender gap life expectancy of roughly maybe 4.2 years. Some of this might be due to, behavior and disease-specific outcomes that might also be gender-specific, such as tobacco and alcohol consumption. But let's delve into some interesting facts. And I recently found out about this a few weeks ago. The lowest life expectancy for women in the world in 2022 was for girls in Nigeria with only 54 years. Why is that? Question that we have to ask. Might be multifactorial, but that is a fact. Another interesting fact: COVID-19, drug overdose, and accidental injury accounted for about 2/3, of the decline in the US life expectancy in 2022. Now, you look at this, you just have to ask this question: why are Europeans healthier than, say, Americans? If you go by, this 2019 WHO gender life expectancy country comparison at birth. Well, for one, European nations practice more preventive medicine, which ultimately results in lower chronic diseases and illnesses, and also a decrease in healthcare costs. All of this, pretty much, lends to the fact that life expectancy and longevity is multifactorial. There's so much that contributes to why certain parts of the world people live to, their mid-70s, or an average high 70s, say in Japan. Also why it's gender-based longevity in certain parts of the world and not in others. In Japan, as you can see, men tend to have a longer lifespan than women. Majority of the world, it's the other way around. Here we have some, more interesting statistics. As you can see, the fastest growing projected population by age worldwide are those 65 and older. And the world population is projected to increase by 3 billion people, even with a steady decline in the population for those 19, and younger since 1950. I mean, in 1950, the world population was 2.5 billion. Projected to 9 billion in 2050. Incidentally, though, the percentage of sub-Saharan African population is 65 and older pretty much remains the same, below 7%, even 30 years from now. However, the greatest population shift over or above 65 is projected to be North America and Asia. Also questions to ask. Why is that? Is there a migration away from, sub-Saharan Africa to, Asia, North America? 30 years from now, I don't think so. Longevity and aging is multifactorial. There's so many other issues, geopolitical, and just so many things that determines how long, we are on this planet. So moving right along, let's talk a little bit about determinants of active aging. So for those of us, for us to fully understand the aging process, we have to first acknowledge that we talked about multifactorial. So we have to acknowledge that so many factors play a role in how we age. Factors such as how much sleep we get, our dietary habits, nutrition, physical activity, general health condition, emotional well-being, physical impairment, not to mention family well-being, financial resource, our cognitive function, diseases, and one that we always seem to, not think much about, cultural factors. They all play an important role in predicting our journey on this planet. And as you could see on the slide, 50% of preventable deaths in the US can be attributed to adverse health behaviors such as smoking, unhealthy diet, which leads to obesity, which, you don't have to look too far, to realize that we have a problem as far as obesity is concerned. Now, moving right along, this slide is very depressing. I found myself, thinking more and more, of this interesting poem by Evelyn McDonald, Old Age is for the Birds. Now, if you look at this slide, you can see why longevity and aging has to be a part of our discussion, a national discussion, a global discussion. It's just looking at the lower left on your screen. Everything is great until you hit your mid-40s. After that, the chronic diseases kick in. Only thing that seems to do better with age, believe it or not, is asthma, the rest, COPD, diabetes, cancer, heart disease, arthritis, they become more and more progressively prevalent as we get older. Just to read this wonderful poem by Evelyn, McDonald, who pretty much nailed it. Old age is for the birds. When I was young and in my prime, I took my health for granted. No major ills in middle age. I never raved nor ranted. So who decreed that when I reach my so-called golden years, a multitude of problems would reduce my life to tears? The feet that once could run a mile now shuffle round the block. The legs that once were straight and true now cause my knees to knock. Just getting up now gets me down. The hip joints creak and crack. Those dizzy spells sure slow me down and spasms rack my back. Kidneys too don't work so good. The lungs are getting smaller. This frame must too be shrinking. Could have sworn I was taller. The eyes that used to read with ease now often shed a tear. I am plagued with sinus problems and it's getting hard to bear. Dentures soon will come my way. My hair is fine and thinning. I can't remember much these days. Alzheimer's now beginning. The sex drive too is on the wane. Old age you just can't fight. It now takes me all night to do what I used to do all night. She's showing me her points. Now, moving on. As you can see, understanding the concept and process of aging is very important. Whether you are a 30-year-old wanting to prevent cognitive decline before you hit your 60s, or a 60-year-old starting to experience cognitive decline or other issues of aging, we all need to have a plan on aging interventions that favors our aging process. This may sometimes warrant early anti-aging, medical intervention. As you can see on this slide, research on aging pretty much today targeting aging, has shown to reduce the burden on numerous diseases. This is a very important slide. As you can see in A, the top graphic A, most of us, we hit, 20s to mid-40s. We're doing good. Mid-40s to 65, we're doing okay. Things start coming in. But from 65 on, we start experiencing age-related diseases. And now, these age-related diseases, with no intervention whatsoever, our longevity, average longevity, say in the Western world, 70, 74. Then, we start talking about death. Now, move on to the next graph, where you have medical intervention as part of the process. When we start getting the arthritis, the COPD, the CHF, you name it, the kidney, disease, we start treating. Once, our subclinical age is still the same, things start kicking in heavily at 65, but with medical intervention, that age-related disease phase that, would give us 5 years without no intervention, now we push it up to 85. We push it from 5 to 20 years. Now you start talking about death on the average around 85. Move down where in a subclinical phase, we start thinking about aging and apply some aging intervention. On the average, you're talking about going all the way up to 80. Okay? And the age-related diseases start, they're unavoidable, but they come later. They start kicking in around, when we hit 80. You're now talking about moving the death or the age-related disease to the centenarian age, which is 200. So with nothing, we go from, we go up to 20, to 70. With medical intervention, we go up to 85. With medical intervention and anti-aging intervention, you're now pushing it to 100. And this has been proven, it's evidence-based. So, moving along, it is widely accepted today that the two leading triggers of aging process are oxidative stress and inflammation. Those are words that you're going to hear quite a bit in this discussion. So what do we mean by oxidative stress? This is a phenomenon caused by, an imbalance, between the production and the accumulation of oxygen in the body. And it affects our energy production and ultimately, the aging process. In terms of inflammation, this can happen, in any organ. So the ultimate goal is to identify the inflammatory triggers and remove them because inflammation will trigger all kinds of stress and accelerates, for the aging process. And, obviously that results in, short journey on the planet. So let's look at this slide. Oxidative stress, as it says, and inflammation cause damage to, organs, mitochondria, our DNA, which happens to be our energy producing factory, and then lipids. And the ultimate, outcome of this, is chronic diseases that give rise to, say, heart disease, cancer, diabetes, and neurologic disease. What are we talking about here? We're talking about things like diabetes, obesity, certain cancers, neurologic diseases like Alzheimer's, cardiovascular, heart failure, oxidative stress, and inflammation have been proven to be a major stimulus that leads us down that pathway. So, keep that's something to keep in mind. Moving right along. I mean, decades of research has shown that caloric restriction slows down rate of aging. I mean, we grew up thinking that we have to eat as much as we could possibly, get our hands on to stay alive. My question is, where did this idea of 3, square meals a day come from? And this is now evidence-based, what we're about to go into about caloric restriction. As you can see on this slide, the end result is what is known as autophagy. For those that may not be familiar with this term, autophagy, I know you're probably thinking it's another medical term. Yeah, it's a medical term, no question about it. But it's a term that is now becoming part of the general public as far as aging science is concerned. Autophagy is the process our body goes through in breaking down, and reusing old, cellular parts so that, we can operate more efficiently. It is a natural cleaning out process that begins when we are stressed or, deprived of nutrients. So autophagy is a good thing. Just think about it. You hear that word autophagy, it's a good thing. It ultimately results in longevity. I know you look at this slide and you're going to see things like, you're looking at mTOR, you're wondering what is mTOR? AMPK leads to autophagy, and that is supposed to extend our life. Well, we all have to get used to mTOR and AMPK. We'll break that down as we go on, because that happens to be the proteins that have been identified that play a process in keeping us alive. And these are things that we have to be mindful of. So, speaking of caloric restriction, diets, the food we eat, and lifestyle changes that can slow down or modify the aging process. I mean, this slide illustrates what is considered to be pro-aging diet. All I can say about exercising, which you see at the bottom, the physical activity, is that we don't stop exercising because we quote unquote grow old. If anything, remember, we get old when we stop exercising. Who would have thought that daily consumption of, say, nuts, fruits, veg would be considered a major part of anti-aging as far as dietary consumption is concerned? Yes, it is. I mean, I look at this, pyramid right at the top. Hey, listen, I am a carnivore. I was born a carnivore, but I am also a clinician. And as a clinician, I believe in data. And the data shows that I am not going to make it to where I'm trying to get to if I eat meat every day. I'm just not going to make it there. Water is good. Red wine is good. However, in moderation, I've been blessed that alcohol has never been part of my existence or tobacco. But I mean, I don't endorse tobacco, but if you want to do the red wine for the antioxidant effects of it, great, do it in moderation. That's all I could say. But key here is exercise and know what he eats. So while we are on this topic of food, when we think about how we can improve our antioxidants, protection, simple things like the ORAC value of a diet can tell us a lot about the potency and beneficial values of certain food products. For those that may not, or just hearing this terminology for the first time, ORAC value, ORAC actually means oxygen radical absorbance capacity. The oxygen radical in foods we eat, the absorbance capacity. So the ORAC score is a method, developed by scientists at the National Institute of Health to measure the antioxidant capacity of different foods. This also happens to be a pathway towards longevity because we all want to keep our antioxidant values, up. Ironically, spices and herbs play a huge role in this, whole process of healthy dieting and longevity. I mean, you look at this, ORAC value. We've long known about cinnamon, okay, being pro-aging. Most of what's up here, I'm sure you have it on your shelves in your own kitchen. However, this is what they do for our body and things that we should pay close attention to. Another classic way to get antioxidant protection is through what is known as phenols. Phenols are, a class of compounds found in many plants, and there are, more than 8,000 identified so far. Together with other dietary agents, they protect us from oxidative stress, leading to cancer, coronary artery disease, and inflammation. We talked about this in the previous slide. I am sure some of you may be aware of the ongoing discussion of, with resveratrol. Resveratrol happens to be a type of phenol found in green tea, grapes, blueberries, raspberries, and nuts, commonly used as, dietary supplements for improving lifespan. An interesting fun fact, though, is that the molecular structure of most of these quote-unquote polyphenols we eat are just physically too large to get absorbed, by our body. So most of the phenols we eat and drink, such as the blueberries, the green tea, the red wine, hardly get absorbed. This is why it is advised to ingest our polyphenols with agents that, would help their absorption, such as olive oil, virgin olive oil. Now, I'm sure you've heard a lot of those nutritionists and dietary, specialists on TV pushing olive oil. This is one of the reasons they talk about olive oil. It's something to keep in mind. We hear a lot about mTOR, AMPK, metformin these days. I am sure most of us are familiar with the diabetic drug metformin. So what do we have to do? What do they have to do, with aging? Valid question. Well, first, mTOR stands for mammalian target of rapamycin and AMPK, adenosine monophosphate protein kinase. The names are not important. Just remember mTOR and AMPK and know their beneficial effects. So question, what are they? One, mTOR are proteins that extend lifespan. And it does so when it is low in our body. The role of mTOR in every cell is to sense the amino acids that we bring in, especially the three main ones, leucine, isoleucine, and valine. Those are the three main amino acids that we bring in, and they sense this in our body. What about AMPK and say metformin? AMPK, on the other hand, controls sugar metabolism. Remember one thing about high sugar. High sugar accelerates aging. It accelerates aging. Like nobody lied to you. That sugar in your coffee, that sweet candy bar, all the things with sugar in it, they accelerate aging. Evidence-based fact. They accelerate aging. This is because the glucose or sugar that circulates, in our body can be used for fuel, okay, which is a good thing, but it can also inadvertently get attached to other good proteins in our body. And when glucose attaches to these proteins, they simply malfunction. And one of the ways to measure the glucose level, say in diabetics, is to measure the glucose that is attached to hemoglobin. And this is known as hemoglobin A1C. I'm sure most diabetics there are familiar with that terminology, hemoglobin A1C. And for non-diabetics, you should also be familiar with it, because it's very important. Also remember, though, that hemoglobin is the protein that makes our red cells, okay, or our red blood cells that binds oxygen in our body. So they have an important role. And also remember that the two critical factors in aging are, oxygen and inflammation. This is one way blood sugar accelerates aging. Hemoglobin A1C, on the other hand, tells us how much glucose we have had in our body roughly for the last month or so, because hemoglobin lasts in the body for about 3 months before it gets turned over. This value gives a good idea of whether, you have been eating badly and or, you have type 2, diabetes. This is another important argument for those of us that swear by continuous glucose monitoring in early in life. By this time, or by the time it hits the range, of type 2 diabetes, it's usually too late. So that is definitely a strong argument for those that believe that we should be monitoring our glucose early, like we monitor other parameters, that, add value to our health. So hemoglobin A1C values, values that are safe that are below 5% is great. 5 to 7% puts us, at that pre-diabetic state. And every diabetic will tell you that anything over 7% is concerning. At 7% or above, that's the level where we start discussing about, treatments of diabetes. So that said, this is where the drug metformin becomes a player. AMPK is activated by a bunch of things for you to remember, for you to know. And this includes hunger or being hungry, exercise, taking the drug metformin. Just thinking about it, you realize that this is why they are all good for us, because they turn on our defenses against aging. So hopefully the concept of fasting now makes more sense because sugar is bad. And if we fast, we can control the amount of sugar that binds to our good hemoglobin. Okay, that, causes, these proteins, that are pro-aging, and drivers of, chronic disease to form. So fasting prevents that. On the other hand, it seems like berberine has been, here forever. We now realize that berberine mimics the effects of AMPK by making the body to think that it is fasting. Berberine is found in tree barks, leaves, and roots of various plants such as the berberry, Oregon grape, and turmeric. And however, as far as we know scientifically, with some of the research that has been done, there has been evidence in human clinical trials in people with type 2 diabetes, that suggests that they are able to reduce blood sugar levels to a similar extent as the anti-diabetic drugs that we're familiar with. And this is why berberine is often called the poor man's metformin. So berberine is over the counter, doesn't require prescription. However, though, if you were to decide that you wanted to go down this pathway, you should be guided by your physician. I am sure that we have all heard of red light therapy. It happens to be one of the new kids on the block. There are scientific papers out there that show that red light therapy at the commercial manufacture wavelength disrupts the ability of cells of mitochondria, to make ATP or energy. This results in low energy, and the AMPK system detects this low energy in our body and starts to provide us with longevity-driven healthcare benefits that we talk about. It has also been shown to stimulate stem cells, protect hair loss, and improve our skin. Just by the look, I'm sure, some of you that may be familiar with red light therapy have, seen people walk around with hats on that, incredibly price-wise, we're talking about hundreds of dollars for a cap that, you wear for maybe an hour a day. And the whole reason or why people, go down this process is that it's been proven or associated with stimulating, hair growth. And this is done through stimulation of our stem cells. And people are using it for that and for numerous other treatments too. There are beds or mattresses that that provide red light therapy, whereby every night 15 to 30 minutes of red light therapy treatment every night. People come out swearing that they feel rejuvenated. So, moving right along, let's delve into hormone replacement therapy. Hormone replacement therapy is a form of hormone therapy to treat symptoms associated with female menopause or male andropause. In men, testosterone, if anything, has been shown to have a negative impact on HDL, which is our good cholesterol. It can suppress HDL. So that's really the only major adverse effect that is commonly discussed. My view on this subject is that I am a strong advocate for keeping the body at young levels. So I am an advocate for hormone replacement therapy for both men and women when needed. Replacement. However, clinical data also shows that while it makes you look good, now we're talking about testosterone, it will not extend your life. And also, there's some myth out there about it causing cancer. And to my knowledge, and I've read quite a bit about this topic, that is a myth. It is unfounded when compared to the general population. So, let's look a little. Look at this slide. For men, everything is good until you hit, after your mid-20s, levels start to decline. In women, after 30s, levels start to decline. As you can see on the slides, common to both men and women: mood swings, depression, headaches, night sweats, insomnia, weight gain, weight gain, bone loss. Those are common issues that are associated with female menopause, male andropause, or male menopause known as male andropause. It does happen. And also go through that experience. So why then are we in favor of replacements? Not just quality of life, but health-wise. Some of the benefits that have been shown in men: it improves energy levels, it increases muscle mass and tone, improves exercise endurance, improves fat loss and muscle tone, improves sex drive and performance, improves memory and concentration, improves sleep, regrows hair on the scalp, decreases joints and muscle aches, joint pains and muscle aches, improves bone strength, improves cholesterol level, protects against heart disease, and many more. On the other hand, in women, it eliminates night sweats, it eliminates hot flashes, eliminates vaginal dryness and itching, eliminates pain within intercourse, improves energy levels, improves fat loss and muscle tone, improves their sex drive, improves mood, improves memory and concentration, decreases skin wrinkles, protects bones from osteoporotic disease, and reduces the risk of heart disease and many more. Sounds like, hormone replacement therapy can be a good thing. So today we have at our disposal the ability to access oxidative load and to determine sources of inflammation, what organs are inflamed, why they are inflamed, and how we can fix inflammatory reactions. As a matter of fact, we are at that level where we can detect chronic diseases and cancers at the early cellular stage before they spread. Remember, monitoring your body can be a good thing. It's been proven it can be a good thing. Most of the cancers that are caught early are very treatable. It is catching them late that can be problematic. And I'm sure there are a lot of people out there that probably are not aware that there are, means out there that are commercially available that can detect cancer at the cellular level before they even leave their cells and get exposed into the bloodstream and spread. Just to give on the screen a list of cancers that can be detected at the cellular level. And those kits are commercially available, but people are not aware of it. Moving right along. Now that we have scratched the surface on the mystery of aging, let's take a deeper dive. Remember, I am a clinician and not a scientist. And as a clinician, most of my training revolved around a reactive approach to medicine as opposed to a proactive one. only fix it when it is broken. Definitely true for my specialty of emergency medicine, which I love. But, hey, if it ain't broken, we don't fix it. We're not trained to fix it if it ain't broken. And that is changing also. If our goal is anti-aging and slowing down the aging process, we are really trying, or what we are really trying to do is decrease the decline, in our organ function. And if our goal is to reverse aging, what we are really trying to do, for lack of better term, is rejuvenation, meaning we want to renew our organ function. Historically, though, anytime we think of trying something new, we always, try to look for animals or plant models in nature that might help, or guide us. A good example is an animal that we are all very familiar with, one that most of us played with as kids, and that is the salamander. The salamander is an amazing, amazing animal because if they lose a limb, they have that ability to rejuvenate and recreate that missing organ. I mean, how cool is that? Question is, how do they do this? Two things. One, omnipotent stem cell generation. Omnipotent stem cells are clustered on the tips of the missing organs, in the tips. The second is the supporting environment. This is very important. A supporting environment that can give the energy or oxygen needed for the regenerative process that we've mentioned earlier. So today, scientists have proven that we can achieve these two goals by applying hyperbaric oxygen therapy. How does this happen? It has been shown that after multiple episodes of hyperbaric oxygen therapy, we have a huge amount of omnipotent stem cells circulating all over, the body, searching for damaged organs to repair and rejuvenate. This happens. It's proven, it's evidence-based. Those of us that are old enough, and even some of the young folks remember Michael Jackson, or when he had that, burn injury and was treated with hyperbaric oxygen. I mean, it looks like Michael Jackson, was on something when he made that statement. Remember when, he quote unquote said, I want to live to see world peace, a world without hunger, a world where children and all mankind mankind know no suffering. I believe if I treat my body properly, I'll live to be at least 150. A little ahead of his time back then. This process of reversing and slowing down aging through omnipotent stem cell rejuvenation is very similar to what happens during the embryonic phase or stages of life, where we have lots of cells that differentiate into different organs, the brain, the kidneys, the lungs, pancreas, etc. So by rationale, this is possible. As you can imagine, the challenge for scientists at that particular time, would have been how to apply the scientific data to slowing down or rejuvenating the aging process in humans. Like any major challenge, in order to prove a hypothesis, you always have to start with the most complex and difficult organ in the body. And in this case, the most complex organ is the brain. the brain is only 2% of our body mass, but this 2% consumes 15% of our cardiac output, and it also consumes 20% of our overall, say, oxygen consumption, and roughly, say, 25% of the total glucose consumption in the body. The brain has some serious demands. I mean, you could even say the brain is pretty much, is greedy. It's only 2%, and it's taking a quarter of glucose consumption from our diet. The interesting thing, though, about the brain is that at any given time, we only use 2 to 5% of our brain cells, only 2 to 5%. Okay. And it takes up all that it takes up. You only use 2 to 5% at any given time. I mean, now there are some amazing brains out there that can, use 10% or more at any given time. I mean, those are the Einsteins of our world. Now, the question we should be asking is, why are we using 2% to 5% of our brain cells at any given time? And the simple answer is that we do not have enough oxygen capacity for more. So the concept of hyperbaric oxygen therapy should start to make some sense. I mean, this is why people in the West Coast, California in particular, are lining up in droves to acquire, membership in hyperbaric oxygen therapy spas to furnish their body with more oxygen. Remember, the two important determinants of aging and longevity is oxygen and inflammation. This is an aging brain. There is a certain area of necrosis or tissue death that you can see in this slide. In that area of tissue death, nothing can be done to help or rejuvenate the dead cells in this brain. However, in the surrounding tissue, if energy or oxygen together with omnipotent stem cells were to be applied, those damaged non-dead tissue in the surrounding area next to the dead tissue can be rejuvenated. And this is evidence-based. It has been proven. Now, looking at this woman in the top right on your screen, this is how she was, after sustaining a stroke or an insult to her brain, trauma to her brain, and see how she is after treatment. Simply amazing. So let's circle back to aging. If we are looking at the aging brain, on the MRI, we can see white patches scattered all over the brain. This is a normal aging brain process. It can be seen in everyone as we age, some more than others. But progressively, as we age, there's a direct correlation, with patches. And this tiny normal aging patches are related to, a slow decline, in our cognitive function over time. This next slide shows the brain MRIs from normal, healthy patients, that underwent hyperbaric oxygen therapy treatments on a weekly basis. If you notice, there are more red lighted spots on their MRI or the brain MRIs of this hyperbaric oxygen-treated patients after 40 treatments of hyperbaric oxygen therapy. This correlates with increased blood flow. This increased red lighted spots on their hyperbaric oxygen therapy treated MRI brains is an indication of blood vessel, quote unquote, rejuvenation. And this has a direct correlation with, improved sensory and motor function, also evidence-based. This same principle of blood vessel rejuvenation also holds true for other organs. So during aging, the occlusion of blood vessels does not only occur in the brain and the heart. As you can imagine, it can also occur with the genitalia, which is what we are actually seeing on the slide. What you are seeing here is the MRI before and after treatment of patients with erectile dysfunction. And the color represents blood flow. So rejuvenation is possible. Whenever I, present this slide, I always, it takes me back to my earlier days in practice as an emergency medicine physician. I had a patient that once came into the ER during an extremely busy time, someone that was very well known to all of us, and had name it chronic disease-wise, he had it. Really tough guy, Vietnam veteran, heavily decorated, also very non-compliant with his medications. And this particular day, he came into the hospital. I walked into the room just to find out what we were here for and how we could be of help. And as I was about to, get a history from him, the nurse came running into the room. Dr. Essen, you gotta go. There's a major heart attack that EMS just rolled in with. And as I was about to excuse myself to tell him that, listen, we'll circle back to him, but I have to run. He said to me, Doc, you're gonna leave me for that? I have had 2 heart attacks, man. This is worse than a heart attack. Okay. I still told him that we'll come back to him and I laughed. Unfortunately, years later, I realized that that was a time when people with erectile dysfunction, say, did not have many options. Their option then was just, treatment with the blue pill, as we call it. But today, there are options, multiple options. So, yes, hyperbaric oxygen therapy, has shown promise in areas that we would never have expected it to. Moving along, that question, where are we heading? Where are we heading? With rejuvenation and precision medicine. While some are blessed with strong and really strong genes and longevity, many are not. However, for me personally, I'm always fascinated, by those that find a way to beat the odds. Now, looking at this timeline, when did this whole concept, of, say, epigenetics or aging studies come about? Way back to 1940s. Move it a little fast forward. 2004, FDA approved the first aging-related drug. Moving fast forward, DNA methylation by Stephen Horvath, which really broke, the science for everyone. And today, you're talking about, I believe in 2020, partial reprogramming, reversing vision loss in aged mice. We have come a long way, my friends, and the future is amazing. Speaking of beating the odds, I present to you two former smokers. According to the Guinness Book of World Records, Jeanne Calment of France was the oldest woman that ever lived. She lived to be 122 years old. But according to a government ID, an Indonesian man, Bagoto, lived to be 146 years old. While these claims can be disputed, it gives rise to questions like, can we develop a test based on blood to verify such claims? I mean, they may be legit, but can we develop a test, okay, that can verify based on blood whether or not a government verified ID is the true age? I mean, just going by how many times you have witnessed the earth go around the sun scientifically is not enough to measure one's true age. And that's becoming more and more, the belief within, the scientific community. So, aging based on blood sample, aging based on skin sample, kidney sample, liver sample, and so on is more reliable. And that's where we are today in aging science. These people, as you can see, are super centenarians. And you're talking about, what is the definition of a supercentenarian? Anyone that has reached the age of 110 or beyond is a supercentenarian, and they are 1 in 1,000 centenarians, not 1 in 1,000 population, 1 in 1,000 of those that are over 100 years old. And I must say, I want to say 2 years ago, or almost 2 years ago, my first person that was a supercentenarian came to was brought into the hospital for COVID-related, complication at 114. Never met anybody before that over 110. So what do most of these people have in common? The FOXO3 gene has been identified. It has a positive effect on life expectancy, of humans. And it's supposedly commonly found in people living to, 100 or plus years worldwide. Hey, if you really want to know whether you're one of them, this is something that's also available that can be determined. If you have that longevity, or you're blessed with that longevity gene. Here we have Bagoto. I'm sure Philip Morris would have loved to use him as the ad or the poster child. He lived to be over 140 years old and passed away in 2017. So moving right along, very important slide. This question of real age was put to rest in 2011 when a geneticist specializing in aging, Stephen Horvath at UCLA, developed an epigenetic clock, a biochemical test based on what is known as DNA methylation that is now used to measure our biological age, and it's widely accepted. It is the gold standard as we speak. This clock allows us to measure the age of every cell in our body, and it has gone beyond humans, and it's also true for non-human, species also. This clock, pretty much brought about the science. When we talk about, the development of the epigenetic clock, okay, it led to, the idea, that since most cells in the human body contain DNA, maybe we can track chemical modifications or quote unquote methylations of our cellular DNA to measure aging, for lack of a better term. Basically, what we are looking for, or we are looking for rust, basically, on the DNA. And as we all know, rust is commonly associated with aging. And that was the presets for, this particular study. We now have a simple epigenetic aging clock that applies, like I said, to all human tissues and cells. So, in other words, the DNA samples from any tissue of the body will give us, the biological age, of an individual. And with that, we can compare it with other chronological ages, with our chronological age. The epigenetic clock has led to two profound discoveries. One, there is no clear separation between aging and development. The clock, these clocks apply to young children, and they also apply to centenarians and supercentenarians. Two, people who have accelerated epigenetic aging, that is those who are, older than the expected based on the aging clock, have a slightly increased risk of morbidity and death. Now, the question also becomes, one, can we do, or what can we do to lower our mortality risk? This question gave rise to the development of powerful aging interventions, which we will be talking about, which is where we are right now, on the aging or longevity world. Two, can we use this epigenetic clock to identify or validate anti-aging interventions or treatment? And the answer is yes. See, today scientists have shown that through these interventions, they have been able to double their lifespan, say in mice, and also their capability of reversing aging in humans. And that has been proven. As you can see on the left, accelerating risk factors and decelerating risk factors. We'll take a deeper dive into this epigenetic clock as we go on with the discussion. As you can see on your slide, the natural process of aging can also be sped up or slowed down, by a host of different things. When it is sped up at its extreme condition, it results in progeria. Now, progeria is an extremely rare and fatal disease that causes the body, to age rapidly. This picture of Sam Burns with his family, as you can see, gives you an idea of, speeding up of the epigenetic clock. Now, for those of you that may not be aware, Sam helped in raising awareness about progeria. Sam, I believe he grew up or lived in Rhode Island, and he died in 2014 at the age of 17. But as you can see, physically, he was in a body of an 80-plus-year-old male, and his parents in the background. If you ever want to watch a very heartwarming, HBO documentary, check out Sam, Life According to Sam. And it really tells a lot about pro-aging and the condition progeria. Well, we're going to talk a little bit about, hormesis and longevity. The key here is that, I mean, we all go through stress. I'm not going to spend too much time on this, but we all go through stress. That hormesis theory and longevity is true. There is a beneficial effect with low stress as far as longevity is concerned, but high stress can be toxic to longevity. It's been proven and it is evidence-based. So many studies out there that prove that some amount of stress can be beneficial. Now, moving right along, future of aging, where are we? Where are we heading along with this? Now the fun begins. What has happened, as far as I'm concerned, in the last 25 years is nothing short of revolutionary when you consider all the breakthroughs in aging science. 10 years ago, Dr. David Sinclair at Harvard University said that the first person to live to be 150 has already been born. And many believe that's true. And since then, so many extraordinary things have happened, which makes, one thing that it's not just 150 years. Historically, medicine has always been, like you said earlier, a reactive art as opposed to a proactive one. And within that context, aging has never been looked at as part of the disease. And this is not right. Today, aging is being looked at more and more by those that study and do this and living as part of a disease. Now, as you can see here, the Human Genome Project, this may be considered as one of the greatest scientific achievements of our time. Actually, I believe it was started during the era of President Bill Clinton, not that the credit goes to him, but he was, it was during his watch. And Human Genome Project, led by researchers with an interest in DNA, genome. I'm sure to the right, most of you would recognize a young Dr. Francis, who he and his partner, were in and out of the media on a daily basis. That's Dr. Fauci, who worked under Dr. Francis. They both retired together last year. This project was launched in October 1990 and completed in April 2003. And they generated the first sequence of the human genome, the human blueprint, which has led to so many discoveries that we can definitely trace back to it. So today, it is widely agreed within the scientific community that we need to tap into our body's natural defenses against aging. And we all have them. We all have natural defenses against aging. This is where the science is at today. This will determine tomorrow for us. Our body, again, has three main sets of defenses or group of genes against aging, two of which we have already talked about. And those were mTOR, which responds to fasting, AMPK, which responds to low energy and lack of sugar. I mean, you want to keep your body sugar, as low as possible. And now the third one is the sirtuins. So this is our body's natural defenses against aging, mTOR, AMPK, sirtuins. Sirtuins was discovered by Dr. David Sinclair at Harvard, and they respond to our daily activities. the things we do, the adversity, the exercise, and the fasting. This group of genes and the proteins, that these genes make can sense our environment. And when times are tough, they fight harder to keep our body safe, protected and ultimately healthier and longer lived, even later in life. So what these sirtuins are actually doing is controlling our epigenome or DNA in our body. I know you're wondering, what is epigenome? If you have never heard this term, think of it like this. Epigenome is our DNA, and we all have DNA. Every cell in our body has a unique DNA strand that is about 6 feet long. So if you consider the fact that the human body has about 100 trillion cells, okay, that means that we have enough DNA in our body to go to space and back at least 10 times. Just to understand the complex nature of our DNA. Every DNA is coded differently. As you can see, the DNA is shown here as the purple strand. It is our body's digital information. I'm going to make this simple. It's our body's digital information. I promise to make this as simple as can be. And then I pride myself on being able, or on being their ultimate reduction. So we will reduce this complex subject of DNA so that it makes sense. So pardon me, from borrowing one of my mentors' explanation on DNA. And this is about, to become DNA 101. So think of the DNA shown here, the purple strand, as our body's digital information. However, the epigenome is not digital. It is mostly analog. Okay, so DNA, digital, epigenome, analog. That's all we need to know at this point. And I know most of us here are old enough to remember analog devices such as, the tape recorder and the CDs back in the days. Those CDs, okay, would often get scratched, cause the music to sound scratchy or funny. This is also true of our epigenome as well. So what is the epigenome? Epigenome is the structure that wraps around the DNA and says, this gene C should be turned on in the brain cell, but turned off in the kidney. And this gene A should be turned off in the pancreas, but turned on in the thyroid. That is the epigenome, the ultimate conductor. So also think of the DNA as the digital information on a compact disc. And the epigenome is the reader or conductor. And it can read different songs depending on different parts of the body. However, scientists in the forefront of aging studies now believe that what is causing aging is the skipping of those songs, skipping of the reader. So what makes the song skip? Scratches on the DNA. So aging is essentially scratching on a compact disc that makes the music skip. And eventually, cells, by reading the wrong genes, skipping the wrong genes, lose the ability to fight against disease. They lose their function, and this results in conditions such as dementia, heart disease, cancer, you name it. That, my friends, is the simplified scientific explanation of aging. So with this new theory, the information theory of aging, is now evidence-based through research. Now, the challenge within the scientific community has evolved around the concept of possibly resetting this epigenome back to being young again. Can the scratch CD be polished back to play the original music of our youth? That's where we are going. That's where we are today with longevity and anti-aging. As we mentioned earlier, Stephen Horvath and his colleagues discovered that by reading changes over time of DNA methylation marks, they were able to estimate our biological age. And by putting this information into a machine learning derived algorithm, they were also able to calculate our biological cellular age, meaning our real age. So if we were to tweak the epigenome, or if we scratch the CD, if the scientists within this field are right about the information theory of aging, if they tweak the epigenome, yes, they get accelerated aging. And this too has been done. It is also evidence-based. If you notice, these are twin siblings at the same time, that are born, at the same time in the same lab. The mouse on the left happens to be the control. It has been tweaked in every scientific way possible, except for scratching its CD or DNA to say. However, the sibling on the right had the misfortune of having accelerated scratching on its DNA or CD. In other words, its epigenome was disrupted, and as expected, its cells started to lose their identity. The mouse didn't feel it, but what happened almost a year later was that aging had taken its full effect on the mouse on the right. That's on the left of the screen. What you see on the right is an older mouse based on biological age. So this is not just a mouse that looks old. It was 50% older than its genetically identical twin. Today, it has been proven by scientists, that we can drive aging as fast as we want. So the million-dollar question now becomes, if we can accelerate aging, can we also reverse aging? And this question also has already been answered. And the answer is yes. As a matter of fact, we now have the ability to reset the age of an entire animal, hopefully leading to one day, being able to reset the entire age of a human being. And this may happen, sooner than we think. How did this all come about? Well, credit goes to an amazing scientist, amazing Japanese scientist, Shinya Yamanaka, who won the Nobel Prize in Medicine in 2012 for discovering a set of embryonic genes that could, take an adult skin cell from any of us and turn it into a pluripotent stem cell that could be, made into another, type of tissue. This eventually led to research that made the cover of Nature magazine and was published in December 2020 with the title Turning Back Time. In this study, interesting, an optic nerve in a mouse was damaged. And you can see on the top image the dying damaged nerve. However, in the reprogrammed eye, where the Yamanaka genes were injected and turned on for 3 weeks, the nerve grew back. The interesting thing, though, is that this new nerve was literally half the age that it was before the Yamanaka genes were injected. Now we have the capability to grow human tissue, and it is currently being done in some major academic centers, some of which I've witnessed. However, we don't know yet if they work in humans. But scientists have been able to grow and model pluripotent stem cells that are engineered into many organs. Well, the question that you might be wondering is, how does this help? Just to give you an example. Just imagine, for one, somebody that gets the news that they have, say, organ failure, kidney failure, and they have to get a transplant list. Imagine if they could bypass that process and have the ability to create or regenerate their own organs scientifically. A lot can be done. This is changing the way and promises to change the way we approach healthcare in the future. Well, you might say this all sounds good, but how long is this going to take before, it becomes a part of our process? I can only, the hope is that we are at a turning point in human history. As important as some of, our greatest achievements, such as landing on the moon, vaccines, and computers, the 21st century, I believe, is shaping to become more and more about biomedical engineering and the ability to control and reverse aging. That, I believe, will be the new disruptive global innovation in healthcare. This, my friends, will radically change our lives in ways we can never imagine. And speaking of radically changing our lives, let's look at where we are today with CRISPR. For those that may not be familiar, CRISPR is an acronym for clustered, regularly interspace short palindromic repeat. CRISPR sounds better. You don't have to remember the rest. What is CRISPR? This is a unique technology that enables editing parts of our genome. It's just like you edit a paper. You go in there, you cross out what's bad, you put in what's right, you think is right, for you to get that complete structure. It's a tool, that simply and cheaply edit the genome of everything from not just humans. It has been applied to non-human, species, also to agriculture. I'm sure some may recall in 2019, CRISPR was used at both Temple University and University of Nebraska to cure HIV with mice. But very low exposure was given to that. This was when we were all going crazy, or around the pandemic era, just about to, get into the pandemic. But there was very little that came out of this as far as public awareness is concerned. Now, the following year, Nobel Prize in chemistry was awarded to Jennifer Doudna and Emmanuel Charpentier for discovering, the CRISPR technology. And CRISPR is part of the future that we're heading. And just think about, when we can reset our age by, by a couple of years, and also be able to edit our genes. Okay. I mean, some of this has already been published by, I believe, Greg Fahey and his colleagues at 21st Century Medicine. If we can do that every year, just imagine how interesting this could become. This is the world we have to do all we can possibly do to stay alive to witness. That said, to all our friends here today, dare I say, be brave, hang in there. Exciting and promising interventions are underway. Thank you very much. At this point, we'll start taking questions and have some more discussions on the aging process and longevity. Thank you.